Welcome back, everybody. Welcome back. I'm glad those breakout rooms are working well. They certainly seem to be. Now it's time to highlight the innovators based at Innovation Crossroads at Oak Ridge National Laboratory. Please welcome Dan Miller, who is director at Innovation Crossroads. Take it away, Dan.
Thanks, John, and I'll echo your sentiments. Wow, it's hard not to get excited listening to all these talented innovators and everything that they're working on. My name is Dan Miller, and I'm the director of Innovation Crossroads at Oak Ridge National Laboratory. Like Chain Reaction and Cyclotron Road, Innovation Crossroads is a 2-year entrepreneurial fellowship program focused on early-stage technology entrepreneurs in the energy and advanced manufacturing spaces. We're sponsored by the Department of Energy's Advanced Manufacturing Office, the Tennessee Valley Authority, and Oak Ridge National Lab, all of which have an interest in developing more high-impact U.S. startups. The premise of the program is that by embedding talented entrepreneurs at ORNL to work with world-class expertise and capabilities, we can enable a greater number of these startups to be successful. In the Innovation Crossroads program, our innovators leverage DOE's largest science and energy laboratory. ORNL boasts many unique facilities that offer world-class expertise in a wide variety of areas. For instance, many of our innovators work with our manufacturing demonstration facility, which is a center of excellence for additive manufacturing, composites materials, digital manufacturing, and roll-to-roll processing. Our innovators take advantage of not only these capabilities, but the thousands of R&D partners that these facilities attract each and every year. Our program is structured similarly to that of the other LEAP nodes at CRI and Cyclotron Road, with a 2-year fellowship, R&D funding, and entrepreneurial training. Across the bottom, you see a summary of the 4 cohorts in our program. Cohorts 1 and 2 have graduated the program, and each of them graduated with enough additional funding to continue growing. You'll hear from our 3rd cohort in just a few minutes, and we brought our 4th cohort on earlier this summer. Here are a few overall metrics for our program. The number on the far right is the additional funding raised by our innovators. And this number has been rising rapidly lately, and we expect it to continue rising rapidly now that our 2nd cohort has just graduated. What's not represented in these numbers are the products that some of our innovators have already brought to market, thus already impacting the economy with innovation. We recruit nationwide and receive applications from coast to coast. The stars indicate where our selected innovators come from, and we're proud of this reach because you have to move here to be a part of this program. And you can see in a lot of cases, people are moving across the country to be here. We're blessed to have a set of partners that, along with ORNL and Innovation Crossroads, comprise a growing and thriving ecosystem. We have a robust advisory network that provides program guidance and rich connections for our innovators. And finally, our application period for cohort 5 opened today, and we'll be accepting applications through October 31st. We want to hear from all entrepreneurs that believe ORNL and our ecosystem can help them build their businesses. See innovationcrossroads.ornl.gov for more info. And now, enjoy Innovation Crossroads Cohort 3.
Hello, my name is Jesse Claypoole. I'm the founder and CEO of MantaPoole Technologies, and I'm here to tell you about the next generation of 3D imaging solutions we're developing. Over the past 30 years, there's been a rise of smart machines. These smart machines have been enabled by advances in sensors, electronics, and software, and have enabled a wide variety of current and emerging applications. These applications range from vision-guided robotics and industrial applications, self-navigating drones and applications ranging from military to logistics, a variety of smart automobile systems, and applications ranging from gesture recognition all the way up to collision avoidance. There's also a variety of emerging applications in agriculture, where essentially you're doing automated agriculture and doing tasks that can only normally be done by the human hand. In all these applications, in order for these smart machines to work, they essentially need to perform 3 action stages. In these action stages, the first one they need to use is use sensors to capture real information about the world. Once they have that information, they then need to use a computer to analyze it and make a decision. Once they've made that decision, they can then send a command to the smart machine's essentially capabilities and then perform an action. And all of these and essentially in these 3 action steps, if your sensors cannot capture the correct amount and type of information, it highly limits the capabilities of your smart machines because they can't then make those decisions and then perform an action. So this is where MantaPoole Technologies comes in. Essentially, we're developing a new type of 3D light field sensor that allows us to capture a lot more 3D information about the real world. Essentially, what we do is we take an existing imaging sensor, and by placing our proprietary micro-optics on it, it allows us to capture much more 3D information about the real world. And because you have all this extra 3D information, you can capture high-resolution 3D over a wider field of view. And again, we only need a single inexpensive imaging sensor. So what are the markets for this technology? Essentially, there's a variety of vision-guided robotics or inspection tasks in industrial manufacturing applications. There's a large number of security camera applications where essentially this 3D information can be used to create a model of a suspect or refocus the image after the fact. There's a large number of facial recognition applications where essentially 3D facial recognition is much more accurate than 2D facial recognition. In the current generation of smartphones, they typically have between 3 and 7 cameras, and essentially 1 or 2 of those cameras could be MantaPoole Technologies cameras. There's also a large number of virtual reality applications where essentially you can import by using these 3D cameras, you can import the 3D world into the virtual environment. And together, these markets will make up a $20 billion opportunity by 2025 where high resolution, fast, and inexpensive 3D sensors are needed. So again, I'm Jesse Claypoole. I'm the founder and CEO of MantaPoole Technologies, and I have a PhD in nanoscale science from SUNY Polytechnic Institute. And together with our funding and support from Innovation Crossroads, a variety of scientists at Oak Ridge National Laboratory, and our advisors, we're looking to commercialize our technology and define the next generation of 3D. Currently, we're looking for technical partners and end users to use our 3D camera technology. So feel free to reach out to us. Thank you for your time.
Hi, I'm Will Fitzhugh, founder and CEO of American Nanotechnologies Incorporated, or ANI. ANI was founded to address problems with purifying nanomaterials. For those of you who are not aware, nanomaterials have been a research darling for the past several years due to their potential to transform a number of electronics industries. However, commercialization of these materials has been slow to non-existent due in large part to the high cost of purification. ANI is developing a novel purification technology known as RDEP, which can potentially reduce the cost of purification by orders of magnitude. The value of RDEP is that by sufficiently reducing the cost of purification, we can finally enable economically viable supply chains for various nanoelectronic devices. Perhaps the most notorious material experiencing this problem is a semiconducting carbon nanotube. If we compare the costs of low purity as synthesized carbon nanotubes with high purity semiconducting carbon nanotubes, we see an increase in cost on the order of 1,000x. This cost increase is a significant problem as nanotubes could otherwise add substantial value for device manufacturers beyond just the current research materials market. For thin film electronics, such as displays and wearables, printable nanotube composites offer the potential to completely eliminate over $22 billion in thin film vapor deposition costs. For high-performance devices, such as 5G and millimeter wave radar, carbon nanotubes offer faster, higher power performance than the current materials, which constitute an $18 billion material market. ANI's RDEP is the solution to this problem. By reducing the costs of purification by more than 100x, RDEP will finally allow these advanced industries to take advantage of the remarkable properties of carbon nanotubes. RDEP is an electrodynamic filtering technology. It removes impurities based on their electrical response, and it minimizes costs by eliminating expensive reagents and low-yield equipment. It's iterative, allowing our customers to custom tailor cost versus purity on an as-needed basis. Additionally, it's non-chemically modifying, which maintains maximum compatibility with the widest variety of use cases. Beyond providing device manufacturers with superior materials, ANI is actively pursuing leveraging RDEP to establish a novel nanotube-based chemical sensing platform. Nanotube-based chemical sensors have already been demonstrated in applications ranging from explosive and chemical weapons detection for national defense, to diagnostics and smart bandages for medicine, to various environmental monitoring and ag tech applications. Despite remarkable performance in the lab, these sensors have seen inhibited commercialization, again due to the need for high-purity semiconducting nanotubes. Thus, ANI maintains a distinct competitive advantage in finally commercializing these sensors. This represents a real 0-to-1 opportunity at ANI, as no conventional, currently available material can satisfy such a broad-spectrum chemical sensing platform. To date, ANI has developed, demonstrated, and patented RDEP. We've secured over $400,000 in non-dilutive funding, as well as a partnership with Oak Ridge National Lab. In the coming 12 months, we plan to establish our first commercial line, reaching minimum viable product and beginning sales into the research materials market. We plan to leverage this commercial line to demonstrate low-cost, reliable chemical sensors and establish strategic partnerships with the relevant sensor stakeholders. The ANI team maintains expertise in a wide range of technical and entrepreneurial domains, spanning all of the skill sets we need to bring RDEP to fruition. Thank you.
Hello, my name is Hicham Ghossein. I'm the president and founder of Endeavor Composites. And today we'll be talking about our nonwoven technology. As you know, carbon fiber has been picking up pace with the industry today. It's proposed to reaching 98,000 tons of production by end of 2020. Sadly, this technology comes with a 30% fibers going up to waste, to landfills. That's because they cannot be produced into a usable product by their end users. That's assuming a $15 a pound average. We're talking about $972 million of material going to the landfill on a yearly basis. With an annual growth rate of about 25%, that will be equivalent to $1.2 billion going to landfill by 2022. Today, Endeavor Composite, with our licensed technology from University of Tennessee Research Foundation, we can intercept these fibers, chop them to 1-inch length, and transform them into a defect-free, nonwoven fabric that can then be sold to the end users. Why this is important? The extra length, the 1-inch fiber, compared to what's available today in the market at 1/2 inch, will provide a higher tear resistance, allowing the manufacturer to process the material at ease, reduce part rejection rate, and lead to more complex geometry parts and freedom of design. The defect-free part will improve mechanical performance and will be much more significant than what the competition can offer. As you see in these charts, with elimination of defect, comparing a available fabric today at 1-inch length with the same composite at the same weight ratio of fibers, our material is performing in the interlaminar shear at 80% improvement and in tensile strength at 50% improvement. Currently, we are part of the Innovation Crossroads program at Oak Ridge National Lab, where we are building up our database for our fabric, and we're collaborating with the strategic partners on development of end product. At the same time, we are building our pilot line scaled-up machine for our technology, which will conclude in Q1 of 2021. At the same time, we're looking at SBIR application and other grant opportunities to continue collaboration with the government. By conclusion of our pilot line, we will apply for a SBIR2 phase grant, and we'll be concluding our time with Innovation Crossroads by Q2 of 2021. From there, we will hopefully get a seed round initiated that will give us an extended runway for 3 years to finalize our full-scale production facility. Today, we're thankful for Innovation Crossroads generous grant that help us get where we are, and in addition to our R&D partner that keeps supporting us through projects and collaboration and advice. If you are an investor and would like to learn more about us, please feel free to reach. And if you are a company that would like to use our product in your product, we're always available for discussion. Last but not least, we want to thank our board of advisors for their continuous support and mentorship.
Hi, my name is Alex Lewis. I am co-founder and CEO of Electro-Active Technologies, a public benefit corporation spun out of Oak Ridge National Lab, where we are working to power cities with waste. Almost 40% of the food produced in the world is wasted, a staggering amount and leading source of methane emissions from landfills. As a result, cities and states are enacting policies to curb food waste around the country and the world. However, options to achieve this are extremely limited, are very expensive, and include long transport distances. Our proprietary technology can take food waste and make affordable, renewable hydrogen, and we can do it on site, enabling us to work with large waste generators as well as waste haulers, providing them a service that can save them over 30% on their waste management and transportation costs while producing a zero-emission fuel in hydrogen. Our underlying technology is known as microbial electrolysis and leverages a robust microbial community that we've evolved and developed with over 5 years of research at Oak Ridge National Lab. These microbes grow as a biofilm on an electrode and can produce electrons directly from almost any organic waste stream. The protons and electrons produced by the microbes are combined with about 1 volt of additional electricity to make hydrogen at the cathode with high efficiency. The system will be scaled up using a stack approach where smaller reactor units are replicated and stacked together to make larger systems. The smaller size of the individual units can de-risk the scale-up process compared to other biological systems. And the use of low-cost materials can make this modular approach economical. Our circular approach to producing hydrogen can result in a negative carbon pathway to produce hydrogen by reducing transport distances, abating emissions from landfills, and offsetting fossil fuel use, providing additional marketable sustainability benefits to our customers. Due to the widespread issue of food waste, there is large growth potential for our company, beginning in California with strong commitments to waste and hydrogen. From there, we can expand across the country and on to the rest of the world, where over 1 billion tons of food waste is produced every year, which could be used to make $78 billion worth of hydrogen. The World Economic Forum recently came out with a statement that hydrogen is no longer the fuel of the future, it's already here. And major companies like Toyota, Shell, Walmart, and Amazon are investing heavily in hydrogen and fuel cells. And countries around the world are laying out ambitious hydrogen use targets, which can be accelerated with this technology. Our long-term vision is to be a part of the smart cities of the future. With the growing amount of renewable electricity produced in the world, there's a growing need for energy storage. Pairing this with the massive amounts of food waste, our technology can store the energy from both waste and electricity in the form of hydrogen, which has the versatility to be used as a fuel, an energy carrier, a source of electricity, or feedstock for industrial processes. The team we have to execute on this vision starts with myself and co-founder Abhijit Barole. I advanced this technology during my PhD, and Dr. Barole is the original inventor and brings 10+ years of experience as a scientist at Oak Ridge National Lab. We also have a great team of engineers working with us in our scale-up and sensor development efforts. We also have a great team of advisors bringing technical, financial, and industry experience to guide our business development, and we also have experienced consultants helping with our sensor development efforts. Building on our work at Oak Ridge National Lab and participation in DOE and NSF I-Corps programs, our company participated in the world-leading IndieBio Accelerator, the H2 Refuel Accelerator in New York, sponsored by Toyota and Shell, and most recently, Plug and Play. Electro-Active is also part of the Innovation Crossroads program here at ORNL, and that's a LEAP lab-embedded entrepreneurship program enabling us to leverage world-leading expertise and resources to advance the technology further. We are now raising a $2 million seed round of private capital to take us through pilot projects, of which we have 1.4 million in the bank. We are raising an additional $600K to close out our seed round over the coming months, and we are also looking for additional partners for pilot projects. Thank you for your attention, and I'll ask you all to join our cause to power your city with waste. Thank you.
Hi, my name is Trevor McQueen, and I'm here today to tell you a little bit about my company, Neptune Fluid Flow Systems, and our work in advancing materials characterization through improving cryo-TEM. But before we get really too into that in depth, let's go to the problem. Pharma has a very big problem. Fully half of their R&D dollars are wasted on irreproducible science. If you've ever wondered why new drugs come about so rarely and why they're so dang expensive, it's because fully half of their R&D dollars are spent on irreproducible science. And this is because on their sample handling side, they're lacking what we call the 3 R's, which are reliability, repeatability, and reproducibility. And in the cryo-TM space, it's far more prevalent than even that. And the problem is that 95% of the times you try to prepare a grid, it fails. That's insane for a modern technology, and it's because they're using sample preparation techniques from the 80s. Our solution is to take sample preparation and bring it into the modern era. We are using a microfluidic jet system to develop the sample preparation technique so that instead of doing it in 3 discrete steps, we do it in a single concerted step, allowing us to go 1,000 times faster than anyone else in the market can possibly do. By going faster, we avoid the problems that currently plague current sample handling, and in fact, we even open up the realm to being able to be used in a vacuum. And now, the market for such technology is actually quite large and growing rapidly. The largest section is the cryo-EM columns, of course, and all the accessories that go with it. But there's some other interesting markets that are also there. You have these service markets. So it turns out there's a lot of users who are working with cryo-TEM who don't want to prepare their own samples. And so they will pay others to prepare it. And we've broken it down to Europe and America precisely because shipping grids internationally is unreliable at best. And then there's the sample device market, which is around $500 million. Now, when we're looking at that market structure directly informs our go-to-market strategy. We're going to start targeting that service market in Americas. Why? Because it's the easiest to enter, has the lowest barriers to entry, and further only has one established competitor, and yet it's still around a $400 million market a year. That's a lot, and we're going to target it first. And as we work in the sample preparation market, the service market, we're going to start exploring whether or not pursuing the device market and the cryo-EM column market will eat our lunch, so to speak. And if it does, then we may not follow them. But currently, we are focused entirely on preparing samples for our users. Now, the team that we have that backs us up is myself and my co-founder, Dr. Winnie Liang. We are further backed by a great technical board of advisors and a great business board of advisors from all around the country who really help us by filling in gaps in our knowledge, helping with business knowledge, with technical knowledge that we just don't quite have. Now, our plan for the next 2 years is we are going to be pursuing our development of our technology, and also we've gotten a REV grant, which is a grant from the state of Tennessee, where we are going to be studying all the different sample preparation methods that currently exist. That's all of them, including ones made by our competitors, and comparing them all directly on the same samples, and building up a chart showing the reliability, the repeatability, and the reproducibility of all the different methods. This chart is going to end up being our sales pitch. We're going to go to all of our potential customers and say, hey, look, we've got the most reliable, repeatable, and reproducible preparation method. Do you want in? So our ask today is if you know anyone who works in cryo-TEM or is interested in exploring cryo-TEM for their company, business, or work in any way, shape, or form, please have them reach out and contact us so that we can get them involved in that REV grant and really prove what is the best way to prepare their sample out of all the ones that currently exist. Thank you very much.
Hello, thank you for this valuable opportunity. My name is Leila Safavi, and I am the CEO and co-founder of Purist, where our main focus is to produce and provide key radioactive ingredients that are used on a daily basis to treat and diagnose various life-threatening diseases such as cancer. Would it worry you if I said the supply and availability of a key medical ingredient that's used on a daily basis for various medical procedures is at risk due to dependence on unreliable foreign resources? This key ingredient that I'm talking about is the main radioactive component of radiopharmaceuticals, which emits radiation that's picked up by the imaging device for diagnostic applications, or that emitted radiation kills the cancer cells and eventually kills the cancer tumor. And Purist's main focus is to produce and provide that key radioactive ingredient to pharmaceutical manufacturers who will compound it into the medical form for various nuclear medicine procedures. Now, what's the problem? Radioisotopes aren't anything new. Radiopharmaceuticals aren't anything new, but as highlighted time and time again over the past decade by various prestigious sources, we continue to have a problem with the supply and availability of key medical radioactive ingredients. And one reason for that is we are currently heavily reliant on 7 main reactor facilities for a fair amount of our medical radioisotope needs. The majority of these reactors, except the Opal reactor in Australia, are close to their decommissioning age. So similar to the NRU reactor, which shut down in 2018, we can anticipate a number of these reactors going offline without any new ones really coming online to replace them. Another problem with radioisotopes is they are time-sensitive material. They start to decay and degrade as soon as they are produced. So you can imagine how highly inefficient it is to produce radioisotopes, say at the Safavi reactor in South Africa, in order to treat a patient in California. Basically, radioisotopes cannot be stored, stockpiled, and they do not have a shelf life. So why don't we increase our domestic radioisotope production capabilities in the US despite having over 20 research reactors available? One reason is with the current technology, only a handful of our big reactors are capable of producing radioisotopes with the purity required for medical applications, and the majority of our smaller scale reactors remain underutilized and dormant to medical grade radioisotope production. And that's where Purist comes in. So Purist has developed a patented plug-and-play technology that can be implemented in these smaller scales, otherwise dormant and underutilized research reactors to produce radioisotopes with the purity required for medical applications. The way we envision our business model is Purist will implement its plug-and-play technology coupled with its unique precursor targets in research reactors nationwide to produce radioisotopes, and then provide these radioisotopes to radiopharmaceutical manufacturers who will compound it into the medical form, and from there on, in terms of how it reaches the patient, will be just business as usual. Currently, we are in our R&D phase, which is funded by the National Institutes of Health, Launch Tennessee, and the Innovation Crossroads program at Oak Ridge National Lab. Our main focus during this phase is process optimization. Upon successful completion of our R&D phase, we plan to shift into commercialization activities, which includes scaling up our production process, certifying our production process, expanding our team, and engaging in strategic partnerships with radiopharmaceutical manufacturers and research reactors nationwide. Purist is comprised of a highly qualified team with expertise in target development, isotope production, reactor operation, business and technology development. We have all come together to accelerate Purist towards commercialization. With that, I would like to sincerely thank you for this valued opportunity, and please feel free to reach out if you have any questions or if you are interested to learn more about Purist. Thank you.
Hi, I'm Jesse Thornburg with Gridfruit. We put unused data to work for food stores and power grids. Using artificial intelligence, we optimize the control of commercial refrigeration to reduce the energy bills for the stores and at the same time reduce emissions and costs for their utilities. Every evening, grids across the US face a spike in demand caused by millions of us arriving home and turning on our appliances. That problem is exacerbated, though, by food stores whose commercial refrigeration often spikes to defrost at the same time. It's a huge load that's easily shiftable throughout time without affecting food quality. Grids respond to this spike by turning on their most polluting and expensive generators. They pass this cost on to the food stores where possible, but in certain regulated markets, the grids have to absorb this cost themselves. Refrigeration is the overwhelming majority of energy cost in the food store, 44 to 62%. And Oak Ridge National Lab finds a fifth of that is wasted. On the demand side, These commercial refrigerations peak 3 times a day with more than twice their average demand. And these peaks often occur by default factory settings in those same evening hours, that are so problematic. Commercial refrigeration has multiple components: a compressor that sits on top of the store, over a mile of circuitous refrigerant lines that go to the front, and those cases in the front where we shoppers walk around. The stores are already collecting data on all these different components: current and power from the compressor, refrigerant leaks, maintenance work orders from the lines, and then the internal temperatures of those cases. Right now, though, that data goes straight to the cloud, and almost none of it is ever seen or used. That's where GridFruit comes in. We take this data of multiple types. It's often noisy and incomplete, so we use artificial intelligence to process it and derive the optimal control signals for the store to reduce their aggregate peak from commercial refrigeration according to the needs of the grid on a given day. This way, we can also recommend preventive maintenance to extend the life of commercial refrigeration and further reduce the store's costs. We've recently been completing a paid pilot with a Southern California utility with their convenience stores, and we've demonstrated we can reduce power by 44% in those evening peak hours, reduce it 30% throughout the day, taking us from this problematic power profile before to these results after, reducing that evening peak from around 21 kilowatts to under 12 kilowatts. This constitutes around $31,000 annually of savings per store, and across the US, that's $4.4 billion of savings, both in the peak reduction that the grid rewards with demand response incentives, but also in energy savings and preventive maintenance life extensions. Our competitors focusing on food stores rely on bulky, expensive hardware solutions to get these same benefits for the grid and the stores that we provide. And we have the added flexibility of software, which provides low-cost customer acquisition and scaling. We're really grateful for the multidisciplinary talented team we've worked with already, starting at Carnegie Mellon University. We have 2 patents pending with them and a no-claim letter to be the sole licensee of those patents. We talked with over 150 potential customers through National I-Corps program, and we're grateful to be in the middle of the Innovation Crossroads program with TVA and ORNL funding us here in Tennessee. As I mentioned, we're now in the middle of a paid pilot with the utility. We've also recently begun an SBIR Phase 1 project with the Department of Energy. In the next few years, we'll be expanding to more paid pilots and scaling to store chains across the US. Our team comes from different backgrounds and a breadth of experiences. My own background is from MIT and starting a solar company called Copo. My co-founder Javad is research faculty at Carnegie Mellon University, and from there we also pulled in a controls engineer, Carolyn Goodman. We're thankful for advisors on both the business and technical sides, and we couldn't be here without them. Really grateful for all our partners in Tennessee, Pennsylvania, and across the US. We hope that you'll become our next partner. Thank you.
Welcome back, everybody from the breakout rooms. Thanks for visiting those rooms, super important. Now, as you heard earlier, all 3 of the Lab Embedded Entrepreneurship programs are now, or very soon, accepting applications to join their next cohorts. Now, all 3 of the programs over the last year or so have been expanding their technology focus as other program offices in the Department of Energy begin to take an interest in the program and sponsoring innovators. One office in particular, DOE's Building Technologies office, put together a short video highlighting what their office is interested in sponsoring. Roll it.
You, a creative thinker with a strong desire to transform the way buildings use energy. Us, a federal agency providing the necessary funding, expertise, and resources to bring your technology to market. We know that buildings are the largest sector of the U.S. energy economy. Residential and commercial buildings use 74% of all electricity and 39% of all energy use in the United States. This is more than any other sector. Therefore, buildings present a big challenge, but also a big solution when it comes to reducing costs and preserving our planet. To this end, We are looking to connect with researchers dedicated to developing the next breakthrough in cost-effective technologies and tools that support building energy efficiency. Originally created by the U.S. Department of Energy's Advanced Manufacturing Office, the lab-embedded entrepreneurship programs are helping creative thinkers turn their ideas into opportunities. Through 3 distinct regional programs, budding entrepreneurs are embedded within U.S. national laboratories to develop and refine their technologies through cutting-edge facilities and collaboration with industry experts. In addition to technological access and support, participants can develop entrepreneurial acumen and skills while connecting with an ecosystem of potential partners and investors.
The reason we are excited about both Cyclotron Road or Chain Reaction Innovations is because in a hard tech startup, it's almost prohibitive to do what we do, like chemistry. You need a wet lab space, you need instrumentation. That stuff is so expensive for a startup company, and it's not something you can write a grant to even afford. So the way we saw it is like, we were not going to be able to do this company without the support from one of these programs.
At the highest level, the biggest impact for us was giving us the opportunity to focus 100% on the technology and the business. In graduate school, you don't have time to focus on the business 100%. And I think a lot of really amazing technologies don't make it to where they need to be because it's too personally risky to go all in. And these programs really allow us to go all in.
We're extremely grateful for the BTO for funding us, and not only funding us, but also they're letting us be a company. And it's not like other sources of funding where you kind of have a set pace that you have to go and you can use the money for only set things. And we're very grateful for that.
Building community, sustaining passion, funding opportunities, transforming the future of buildings. That's what we do.
Well, thanks so much, everyone, for attending CRI's Demo Day 2020 event. We hope you've really enjoyed this year's guest speakers and presentations. We encourage everyone to visit Chain Reaction Innovation, Cyclotron Road, and Innovation Crossroads websites and learn more about these programs. And of course, if you want to, apply to join their next cohorts. To all those ecosystem partners, we can't do this without you. Thanks for your support. A big thanks to our VIP speakers, David, Samir, Paul, thank you so much for your efforts there. A huge thanks to the CRI team and also the teams at our sister programs for putting on the event. I'm looking here in the studio at Dina, John Akins, Adria Wilson, Renard Johnson, and Janelle Richmond. Thanks so much. And finally, a huge thanks to the innovators, all the innovators in our program. It's hard enough to commercialize energy hard tech in normal circumstances. Watching these people persevere through a global pandemic while trying to do that it's just truly an honor and a pleasure to help you make your visions a reality. Okay, now to finish off the great event, please join us immediately to network in the virtual booths. And I have late word from the CRI team that we have some extra t-shirts that we can give away. So we're gonna pick 3 people at random and we're gonna give you a t-shirt that we happen to have in surplus. Well, that's it. And from Chicago, thank you so much for attending, and we'll see you next year.